Morning everyone. My name is Hemanth from CSU second year from SRIT College. Today my topic is about define generating functions and find the sequence generated by the function 1 plus 3x in subject district mathematics and graph theory. Generating functions. A generating function is a formal power series whose coefficients represent a sequence of numbers. Generating functions are particularly useful in combinators, common, the combinatorics, number theory, and other branches of mathematics because they provide a compact way to encode an infinite sequence. Definition: if you have a sequence A0, A1, A2, so on, A A underscore 0, comma, A underscore 1, comma, A underscore 2, so on, the generating functions for this sequence is given by g of x is equals to a of a0 plus a1 into plus a2 x square plus a3 x cube plus so on. This series is formal power series, meaning that it is considered more as a tool for understanding the sequence structure rather than for evaluating at specific values of x. There are different types of generating functions. The order of different types of generating functions. One ordinary generating function, second exponential generating functions, third direct generating functions, fourth position generating function. OGF. G of x is equals to sigma infinite n is equals to 0 a n x power n, where an represents the nth term of sequence. EGF. G of x is equals to sigma infinite uh, n is equals to 0 a n x power n by n factorial. DGF. G of s is equals to sigma infinite n is equals to 1 a n by n of s. Position generating function, often used in probability and relation, finding the sequence generated by 1 plus 3x whole power minus 1 by 3. Let us focus on specific function 1 plus 3x whole power 1 minus 1 by 3 and find the sequence it generates. Binomial series expression. We use it to binomial series expansion to find the generating function. The binomial series expansion for 1 plus x whole power n is given by 1 plus x whole power n is equal to sigma infinite k is equal to 0 of n k whole x power k. When nk is binomial coefficient defined as nk is equals to n of n minus 1 into n minus 2 so on n minus k plus 1 by k factorial is equals to n factorial by k factorial of n minus k factorial. In our case, n is equals to minus 1 by 3 and is replaced by 3x. Therefore, the series expansion becomes 1 plus 3x whole power minus 1 by 3 is equals to sigma infinite k is equals to 0 of 1 minus 1 by 3 k of 3x whole power k. Binomial coefficients for n is equals to minus 1 by 3. The binomial coefficients of minus 1 by 3 k can be expressed as minus 1 by 3 k is equals to minus 1 by 3 into minus 1 by 3 minus 1 into minus 1 by 3 minus 2 and so on minus 1 by 3 minus k plus 1 by whole by k factorial. Let's compute the first few terms. For k is equal to 0, minus 1 by 3 of k of 0 is equals to 1. K is equals to 1. 1 power minus 1 by 3 is equals to minus 1 by 3. K is equals to 2. 2 power minus 1 by 3 is equals to minus 1 by 3 into minus 4 by 3 by 2 factorial is equals to 4 by 18 is equals to 2 by 9. K is equals to 3. 3 whole power minus 1 by 3 is equals to minus 1 by 3 into minus 4 by 3 into minus 7 by 3 by whole 3 factorial is equals to minus 28 by minus 162 is equals to minus 14 by 81. With With this coefficient, we can write out the first few terms of series expansion of 1 plus 3x whole power minus 1 by 3 is equals to infinite sigma k is equals to 0 of k power minus 1 by 3 into 3x whole power k. Substituting the values we have calculated, 0, k is equals to 0. 1 plus 3x whole power minus 1 by 3 is equals to 1 plus so on. K is equals to 1. 1 plus 3x whole power minus 1 by 3 is equals to 1 minus 1 by 3 of 3x plus so on is equals to 1 minus x plus so on. K is equals to 2. 1 plus 3x whole power minus 1 by 3 is equals to 1 minus x plus 2x 2 by 3 2 by 9 of 3x whole power whole square plus so on is equals to 1 minus x plus 2 by 9 of 2 9x whole square 9x square plus so on is equals to 1 minus x plus 2x square plus so on. K is equals to 3. 1 plus 3x whole power minus 1 by 3 is equals to 1x plus minus x plus 2x square minus 14 by 81 of 3x whole cube plus so on is equals to 1 minus x plus 2x square minus 14 by 81 of 27 whole cube plus so on is equals to 1 minus x plus 2x square plus so on. So putting it all together, the first few terms of generating function of 1 plus 3x of whole power minus 1 by 3 are 1 plus x 3x whole power or minus 1 by 3 is equals to 1 minus x plus 2x square minus 14 by 3 into x cube plus 335 by 243 x whole power 4 is equals to plus so on. This corresponds to response 1 comma minus 1 comma 2 comma minus 14 by 3 and so on. Conclusion: generating functions provide a complexity and influences y to conclude in encode sequence by using the binomial series expansion. We have to transfer the function 1 plus 3x whole power minus 1 by 3 into our series and extracted the corresponding sequences. These sequences can be shown in future mathematical analysis for problem solving. Thank you for giving this opportunity.